The Nisar satellite, a joint project between NASA and the Indian Space Research Organisation, ISRO, will monitor small changes across the Earth's land and polar regions. This new radar satellite, successfully launched on Wednesday, aims to track minute changes in the Earth's surface and polar ice with centimeter-level precision. This mission is the culmination of over a decade of scientific collaboration. Nisar, NASA ISRO synthetic aperture radar, was launched from the Satish Dhawan Space Center on India's southeastern coast at 15:40 and entered a polar orbit approximately 745 kilometers above the Earth about 20 minutes later, passing near the North and South Poles. The successful launch was met with widespread enthusiasm at the Mission Control Center, with thousands of students present and tens of thousands watching online. V. Narayanan, ISRO's director, remarked, "This success represents true international cooperation between the two spacefaring nations." NASA's Deputy Administrator, Casey S. Wells, added that this unique mission in Earth sciences showcases the combined capabilities of both countries to the world. NASA describes Nisar as the most advanced radar system ever launched. Using synthetic aperture radar technology, the satellite can observe the Earth's surface through clouds and in any weather conditions, even at night. Paul Sequeira, a professor at the University of Massachusetts and head of the Nisar Ecosystems effort, stated, "We can see the Earth's surface whether it's day or night, raining or sunny." Nisar's mission is to detect minor changes in the Earth's surface to provide early warnings of natural disasters like landslides or volcanic eruptions. The satellite will also provide crucial information about changes in glacier and ice sheets by measuring their precise levels. Another important application of Nisar is to identify flood-affected areas in adverse weather conditions, aiding rescue teams. For instance, Nisar data could have been useful after the recent 8.8 magnitude earthquake along the eastern coast of Russia and the subsequent tsunami. So Owen, deputy scientist at NASA's Jet Propulsion Laboratory, emphasized that these types of events remind us how critical Nisar measurements will be. These measurements help us predict the occurrence of natural disasters and assess damage following earthquakes and tsunamis, he said. In the initial 90 days, the complete spacecraft commissioning process will occur, including the deployment of a 12-meter golden mesh antenna, similar to a large beach umbrella, testing instruments, and initiating early observations. The primary mission duration is set for 3 years, but the spacecraft has enough fuel for additional years of operation if performance remains optimal. Synthetic aperture radar technology, which simulates a much larger antenna by sending and receiving multiple radar pulses, has been used in space for decades. For example, a version of this technology was utilized during the 1994 Shuttle Endeavour mission, successfully identifying buried urban remnants on the Arabian Peninsula and archaeological sites along the Silk Road in China. What sets Nisar apart is its extensive and repeatable coverage. The satellite will scan nearly the entire surface of the Earth twice every 12 days. This capability allows scientists to detect subtle changes, such as very slow landslides, and monitor remote, uninhabitable areas like Antarctica. Eric Rhino, a glaciologist at NASA's Jet Propulsion Laboratory, noted, "For the first time, the entire Antarctic continent will be covered by Nisar. Conducting various measurements from the ground in such a vast area is practically impossible." Nisar's data will be used in climate models to predict sea level changes in the coming years and decades, helping prepare for the protection of human communities. Another application of Nisar is tracking agricultural crop growth. According to Dr. Sequeira, microwaves reflect off water, causing healthy plants to appear brighter, while dried plants exhibit more radar transparency. The Nisar spacecraft measures about 5.5 meters in length and weighs over 2.5 tons, powered by two 5.5-meter solar panels. It is equipped with 2 radar systems, one from NASA with a 10-inch wavelength and another from ISRO with a 4-inch wavelength. 2 wavelengths allow for the observation of details on various scales, from shrubs and bushes to tall trees. The data generated by Nisar is extremely vast, reaching several terabytes per day. One of the challenges in mission design was how to transmit this immense volume of information back to Earth and process it efficiently. According to Joel Baden, the project's lead scientist, Nisar's massive data volume prompted NASA to move towards cloud data management. The idea for a mission like Nisar stems from proposals made in the decadal reports of Earth science researchers. To secure funding and resources, NASA reached an agreement with India in 2014. According to NASA, the agency's share of the mission's cost has been around $1.2 billion, with ISRO's financial contribution estimated to be similar. In recent years, US-India space collaborations have increased. Recently, an Indian astronaut named Shubhaman Shukla traveled to the International Space Station on the private Axiom 4 mission, spending 18 days in Earth's orbit. Although a collaboration as significant as Nisar has not been repeated, officials from both countries have repeatedly emphasized the necessity of continuing these partnerships.